Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled "To Fly Free in Space." So what do we see here? Well, here we see an image taken from one of these space shuttles, and this was back in 1984. And we see the Earth down below, and off in the distance we can see an astronaut. Now, the astronaut here was using what was known as the Manned Maneuvering Unit, or MMU, and that was a way to be able to conduct a spacewalk without being tethered to the ship to which you were traveling or with which you were traveling. Now, so spacewalks had been done before, but the astronaut was always attached to the ship, and that limited their mobility. So they had a cord connecting them to the spacecraft. And now with this, they are able to travel free. And that's what we can see, the one astronaut taking a picture of the other off in the distance there, nearly 100 meters from the cargo bay of the space shuttle. So about the distance from end zone to end zone in a football field would be similar to how far away this astronaut was from their spacecraft. Now, how do they move around? Well, the only thing you can do out in space is to use Newton's third law of motion, which states that for every action, there's an equal and opposite reaction. So you have no way to move. You can't swim as you would through the water moving your arms because there's nothing there. You are out in space. However, what you can do is shoot gas out in one direction, and then you will move in the other direction. So little jets of gas could be pushed out opposite the direction you want to move, and then in that case you would continue moving in that direction in a straight line until you did something to stop it. So that's one of the things you have to keep in mind out in space, is that we're very used to things like air resistance and friction that slow us down, and that all you have to do is take your foot off the accelerator pedal and the car begins to slow. However, out in space, if the astronaut starts moving at a certain speed in a certain direction, unless they then use their maneuvering unit to slow themselves down, they will continue to move in that direction and at that speed. Which goes back to another one of Newton's laws, which would be Newton's first law of motion, or the law of inertia. So we can kind of see a little bit of both of those here with the astronaut out in space. The astronaut will stay in one spot or move in a straight line under constant motion, as Newton's first law says. And the way they can move is by using Newton's third law, by propelling something off in one direction, which then propels the astronaut in the opposite direction. Now, the unit itself had a mass of about 140 kilograms, and a weight then on Earth would have been 300 pounds. So you can imagine how bulky and unwieldy that would be here on Earth. However, when in orbit, essentially it becomes weightless. So it really adds nothing to the weight of the astronaut, making it much easier that an astronaut can maneuver heavier objects like this or help move satellites because of the lack of gravity. That things you would not be able to begin to lift on Earth can be moved very easily out in space. So that was our picture of the day, titled "To Fly Free in Space." We'll be back again tomorrow for the next picture, previewed to be Unexplained Shocks. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.